This is Mrs. Yule.
Hey, this is Mr. White. What are we doing today?
We are going to take a look at the special right triangles and how they're used to develop the unit circle.
Cool. Okay, so we have three special triangles. Well, kind of just two, right? One's just flipped, but we'll treat it as three. So what do we do? What's the first one?
The 30, 60, 90.
So we'll say that this clearly looks like it's 30 degrees, at least the smaller one. So opposite of 30 is
1.
That's good. Good job. Okay, and this one is 60 degrees. Opposite of 60, let's see, I think the hypotenuse is the longest side, so that one's 2. And this one will be
Root 3.
root 3. Okay, let's just turn that around. We're going to do both of these, but it's literally just the same triangle, just sort of flipped and turned. So that one will be root 3. This one will be 30, which would be 1. 90, of course, and what's the side? 2.
2.
That will stay the same. All right, and then the last one?
We're looking at the 45, 45, 90.
Okay. And what's the shortest side? Well, the shortest side is always 1,
1.
right? That's sort of how they've developed these. And then use the Pythagorean theorem, you can easily show that this hypotenuse is root 2. Okay, so now what we have here, this should be reviewed to you that these are the special triangles, and there's 3 of them, sort of just 2 of them. But we're going to use these special triangles to develop what's called the unit circle. And the unit circle sort of opens a huge can into trigonometry. Okay, so how do we get started? Well, let's first talk about what this circle is. This circle is literally centered around the origin. This is 0, 0, and its radius 1. So, Miss Yule, what's this point?
That point would be 1, 0.
Good. Let's just go all the way around.
0, 1.
Nice job.
Negative 1, 0.
Perfect score.
0, negative 1.
All right, nice. Okay, so then the next thing we want to do is we want to fill in all of these points. And we're going to start by just filling in the degrees. So we'll start with just this first one, and this here is corresponding to this line, 30 degrees. Okay? Oh, no, never mind. That's 0 degrees. So this is 0, and this one's 30. Okay? What's this one?
That would be your 60.
No, this one's 60.
Oh,
this one's 45. Okay? This one, big fat 90 degrees. Good. Okay, add 30, we get 120. Add 15, you see that these differences are 15. It goes 30, 15, 15, 30. 30, 15, 15, 30. Okay, so that's 135.
35.
And then arithmetic, 150.
And 180.
Semicircle, yeah, 180. And then add 30, that's 210. 225. What's this one? 240. Add 30 more, that's
270.
270. 30 more, 300, right? 300.
Yep, 300. 315.
315. 330.
30.
Good, I was going to write 345. And this one is 360.
360.
Good, so that's all the way around. Now what we're going to do is develop what's called a radian. Before we get into adding these points, we need to add in what's called radians. And unfortunately, degrees are arbitrary. I mean, they just picked degrees. But radians actually have some meaning. Meaning it comes from the circumference of a circle. The circumference of a circle is 2 pi r, as you know. And the radius, in this case, is 1. So that means all the way around the circle is 2 pi. So this one's 2 pi, and this one is 0. All right, Miss Yule, what's half of that?
Half of that would be pi.
Half of that would be pi, and half of that?
Pi over 2.
Pi over 2. Half of that?
Pi over 4.
Pi over 4. Okay, so those are the easy ones. Actually, we can tack this one in. That's 1.5 pi.
3 pi over 2.
3 pi over 2. Okay, so now 30 is a third of 90. 30 is a third of 90. If I divide 90 by 3, that'll give me 30. So if I divide pi over 2 by 3,
get pi over
I'll
6.
get pi over 6. Okay, we can do the same thing. We multiply 90 by 2/3 if we want, or we can just multiply 30 by 2, or pi over 6 times 2, which is
pi over 3.
Yeah, 2 pi over 6, or exactly pi over 3. All right, then jump over here. They get it. Actually, let's jump down here. This is a little bit easier. I'll show you how I do this. This is nice. I'm adding pi every time. See, this is like directly 180 degrees later. Like I go pi over 3 plus 180. So that's pi over 3 plus pi. So pi over 3 plus pi, which is 3 pi over 3.
4 pi over 3.
So that's 4 pi over 3. Good. The little trick is that this is a 1 pi over 3. 1 plus 3 is 4. Keep the same denominator. 1 plus 4 is 5 over 4. Keep the same denominator. 1 plus 6 is 7. Keep the same denominator. Okay, so that's a quick way to get that third quadrant. What about the second quadrant? Let's see here. Well, how can we do this? Let's do, this is 30 degrees, which is pi over 6. That is 30 degrees, so it's pi over 2 plus pi over 6, which is 2 pi over 6. 2 pi over 3. We'll just jump into this, but I have a quick way. This is 2, 3. This is 3, 4. This is 5, 6.
I never thought about looking at it that way.
2, 3. Well, it's actually 1, 2, 2, 3, 3, 4, 5, 6, which is nice. And then we can add pi again, just like we did with the third quadrant. So 2 plus 3 is 5. 5 pi over 3. 3 plus 4 is 7. 7 pi over 4. Keep the same denominator. And 5 plus 6 is 11. 11 pi over 6. Miss Yule, how did I get that 11 pi over 6 again? I forgot. I did it several steps. I explained it several steps ago over here.
You added pi to 5 pi over 6.
5 pi over 6 plus 180 degrees, 150 plus 180. That is, pi, so 6 pi over 6, which is 11 pi over 6.